Hey guys, and welcome back to episode 2 after some save file corruption. Yes, last episode we did the suborbital flights of Kara 1 and Kara 2, through the mission controller mod, and unfortunately we had a little bit of issues with save files, considering I tried to add some more mods and broke it. So we're back to exactly the setup that we had last episode, with the Kara 3 mission on the tab, which is what we set up to do last episode as well, where we're going to attempt to achieve our first orbit of somewhere in between 70 kilometers and 100 kilometers, relatively circular. So we're going to accept this for a prize of $36,000. We're going to go ahead and hop into the VAB here. And we're going to get to work on our ship. I've actually already constructed what we're going to need. However, I started to have a little bit of second thoughts about this, because I had this limited back at first, and then I thought about it. And I don't think this is enough to get us into orbit, because we're going to need going through the vacuum, and unless we do this perfectly efficiently, it would probably be a little bit easier to carry some more fuel. So we're going to experiment around with what would happen if we instead did... It's stuck on my screen for some reason. Actually, real quick, let's see what the cost was of the vehicle when it just had the solid fuel booster. It was $22.87. Alright, $22.87 compared to, let's try it. If I hooked 3 of these up, and then put 1 of these on the bottom, what's our thrust weight look like? See, now that raises it up. Of course, it's quite a bit more expensive, considering this was 22.087, and this is 28.052, but this is going to be more than enough to get us where we need to go. And we're going to go ahead and slap the winglets on it. So, even though that's a less efficient way of doing it, this is going to make it, 1, easier to fly, because it's throttleable, and 2, as long as we're beneath the payout of the mission, we should be okay. And the vehicle is worth about 30 grand right now, and the payout is 36. So we're fine. We have a $6,000 in the black increase there, which efficient space program still. So we should be okay. I'm actually gonna lower these down a little bit. There we go. So this thing, in theory, should be enough to get us to orbit. We're gonna take out the EVA fuel actually, because that'll save us a few $100s. And then we're going to go ahead, make sure our staging is correct, and we're going to light this candle. So, let's go ahead and launch this. Now, funny thing you'll notice that as I was playing this back up point after the save file fiasco, is that you can actually see, as we're burning fuel, the vehicle budget burns right away. So you can see the Kerbal taxpayer dollars being turned into... liquid exhaust, which in this case, I would assume these would probably be something like hydrogen-oxygen rockets of cryogenic hydrogen with cryogenic oxygen as the oxidizer. So you can see it being turned into water vapor off the back of the spacecraft. So now we have the Kerbal Engineering System layout over here with all our good stuff, including the delta V for the rocket, specific impulse, all that great stuff. You can see the specific impulse is now higher, because these are more efficient than solid rocket boosters in terms of their fuel-to-thrust ratio. And it even throttles with you, so you can see your thrust-to-weight ratio as you throttle up and you throttle down. So we're going to slap the SAS on, and we're going to take a look over here at our orbital display. As you can see, these numbers are all wonky, because we are currently sitting on the launch pad and not in orbit. But the numbers that we're going to look out for an efficient launch to orbit here are just going to be our apoapsis height and our time to apoapse. And I'm going to go ahead and throttle us up to about 80% and get us rolling here and explain as we go up. So ideally, we want to ride this booster stage here until we're about 10 kilometers up, and then we want to separate this, or if we still have fuel in it, that's fine too. We want to bend over to the 45-degree mark to the east right here. And the reason that we're going east is because that follows the rotation of the planet Kerbin, and it will allow us to pick up about an extra 200 meters per second as we use the planet's rotational velocity to our advantage, and we don't have to counteract it. So, as we proceed up through the atmosphere here, you'll notice our apoapse rising faster than our actual altitude is rising. That's already going up way up. And our thrust-to-weight ratio is getting higher, so I'm actually going to go ahead and throttle back a little bit and pull us back, pitch us back over here where we need to be. And we're going to pitch hard because this thing is being unruly. Want to get it up above 10 kilometers there, get through the thick part of the atmosphere, and then we'll get nice and easy to fly. This will also get much easier to do once we unlock some of the control surfaces that have ailerons and such on it, or actual moving control surfaces instead of just these stabilizers as they are now. Right, so here we are above 10 kilometers. We're going to go ahead and execute our turn here. We're going to throttle up so we move the velocity a little bit faster in terms of transferring it to our new vector. And we're going to go over here and hold that thought right there, just because we don't want to cause any side slipping as you're seeing up here on Ferrum. We want to bring it nice over to the 45 here. And actually, we want to come over a little bit farther than that, because this is going up way too fast. We're looking for something right around 85 kilometers, though, so we're going to kill it right now. And there we are. We have 156 meters per second left in this stage, which isn't really all that much. I'm actually going to go ahead and burn off the stage just so we can use it all. We're going to put it right on 90. That way our apoapse does not go up by much, and we can just increase our sideways momentum here and burn out this stage. All right, so that's that stage burnt out. We're going to go ahead and do a stage separation. Throttle down the engine, turn that engine on, and here we are with 2 kilometers a second of delta V to get ourselves into an orbit. Now, we're going to place our maneuver node and go ahead and drag that out until we have a nice little orbit there. That's 59. Want a little bit higher than that. 77. 79. We're going to take it right about 80. Now, see, that's getting inefficient, so we're going to want to do so than that. If we have to trim it once we get up, that's okay. Really, I just want this direction, and it does not recognize a burn, so I'm going to do a little bit of test burn here. There we go. We need 29 seconds, so we're going to start burning right at 14.5, because the maneuver node system works in terms of instantaneous velocity. So it's thinking that if you change your velocity by a factor of 1,465.3 meters per second right at your node, that's going to get you into this orbit. Now, of course, we do not have the capability of instantaneous velocity changes, so we need to burn at an equal distant amount on either side of the node, which is half of your estimated burn time. So we're burning on 14.5 seconds on this side of the node and 14.5 seconds on the other side of the node. And we're going to go ahead and get ready to burn here and start our burn. And we have about 30 seconds of fuel. It's not quite ideal. We're going to go ahead and just make sure we make an orbit. This engine is more of a booster type engine than an orbital maneuvering engine, so it's not exactly the most efficient thing ever to use when you're in space. Now, there we are in orbit. So now we want to push our periapse up just a tiny bit. And of course, if we burn a little bit over, that's okay, because we can just turn around and burn back down. And we're going to keep it at 80. So now we're in orbit. We have about 564 meters per second of fuel left, or 6.9 seconds if we're at full throttle, which we're not intending to do. So this is an orbit. See a nice pre-orbit here. It's a little bit inclined. It's not quite equatorial, which is okay, because we're not going for an equatorial orbit at the moment. And we're going to burn this side back down. So we want to drop the periapse, or the apoapse, back down into our mission parameters, which is somewhere between 70 and 100. So we're going to go with this burn right here. And that is going to be a 1 second burn, because we only need to change 94. And we're going to flip over and point at retrograde. Should be pointing anyway. And that's going to be a 1 second burn in a minute 36. So, anything else I want to talk about while we're up here in orbit? You'll notice the specific impulse of our engine has changed now that we're out of the atmosphere into vacuum. Engines are more efficient in vacuum because they are not fighting the atmosphere, of course. And the you can also see the original mass of the stage compared to our mass now, because we burned off quite a lot of fuel. And, you know, we don't have a ton of fuel left. Actually, in theory, this would be enough to return. We could go probably to Minmus. We wouldn't be coming back from Minmus, and that's not the mission parameters this time around, so we're not going to do that. I'm not really sure why that's turned red. I don't know if that's a good thing or a bad thing. I guess it's because our current budget has dropped really low, because I didn't bother to do things quite as efficiently the second time around, because I just wanted to kind of bang it out. But we should be okay. We're just hitting some hard budget times. You know, it's the middle of the Kerbin Cold War, of course. So we're going to go ahead and actually do a little bit of 2 times time acceleration to get us back around to this. And then we're going to just go ahead and wait 9 seconds, 8 seconds. And what we're paying attention to is we want to drop this back down around 100 so we can achieve our proper orbit. And we're going to start burning. We're going to do it nice and efficient, so I have the control here. A little bit higher than that. And we want to bring it down under 100. That should fulfill our mission parameters as far as I'm aware, not settings. Let's see here. Did that configure visible buttons? Let's see. Select current mission. And let's go to the mission. We are... This should be a finished goal, isn't it? Hide. Yes. All we have to do now is land. So, in terms of landing, we have plenty of fuel to bring us back down. We actually probably, most efficiently, we wanted to complete an orbit and do a periaps. Real quick, I don't know if we actually get different crew reports from being in orbit. We do not. Okay. Or being in EVA, just because we're so close to the planet, so we're not going to worry about that right now. We will get a little bit of science for bringing it in, bringing a vehicle that was in orbit back to the surface and safely recovering it. Now, we're actually going to go ahead and time accelerate here, because I want to bring it around to the day side of the planet and land in the daylight, because landing in the night would not be ideal, because it's going to be hard to see. And it would also be hard for, you know, recovery ships and stuff to spot us once we get down. So, here we are. We're going to go ahead and think about doing our deorbit burn now. We're going to put ourselves on our nice, we're going to delete this maneuver node, and we're going to put ourselves on the retrograde. And we're just going to throttle up this engine and drop our periaps down into the atmosphere. And we can go ahead and kill it right about there, because even though we still have some fuel left in this engine, we do not want to bring it straight down, because that would be, that would not be the way to do it, because that would cause you to come in very, very fast, compared to bringing it down to something like 28, so we hit the top of the atmosphere and let the atmosphere slow us down. In fact, we might want to bring this down to more something around the lines of 20, just to make sure we do indeed get captured. Letting the atmosphere bring us down is, one, more efficient because we use less fuel, and two, it also allows us to come in slower. So, that's that all completed, and this stage is probably going to impact, or if it does not break up in the atmosphere due to an aerodynamic failure. So we have no use of this anymore, so we can bid farewell to it. And now, we're just going to let the capsule fly itself on in, as it will. And we're watching our, we can actually flip over, we don't need this anymore, we can switch to a surface and watch our altitude, and flip the SAS back on there, and get us right on retrograde. That way we're entering with the blunt end first to protect us. Heat shield on the bottom would be ideal. And it's going to tumble as it wishes, apparently. So we're going to leave the SAS on right there, I guess, yeah. And watch ourselves come in here. 85, 84. Now, a little bit of basic physics for you there. You can see our vertical speed increasing as we're falling at a little bit under a G of acceleration right now, but since we are coming in not quite vertical, in terms of we're still technically in orbit, although now we are slowing down. But our horizontal speed is remaining completely the same, because, of course, we're in a vacuum, so there's no forces acting on us this way, even though gravity is acting on us this way. So we are going to accelerate vertically. However, we're not going to see a change in velocity horizontally, although now we are picking up a little bit of speed because we are falling horizontally as well. And, you know, that's just resultant speed from coming in at falling closer to the planet at the trajectory that we're falling at. And we are going to see our interface here with the Kerbin atmosphere coming up in just a few seconds as the Ferrum decides it wants to freak out the spacecraft. Try to get back on the straight and narrow here as we enter. We actually no longer need the vessel display either, as that does not matter anymore because all the vessel left is this. It has no delta V. Now, we're going to see, we're picking up interface. You'll see on the Ferrum Aerospace panel here, we are currently doing Mach 7.6 and decreasing because we are slowly passing through the atmosphere, and sound is actually getting slower because at thicker parts of the atmosphere, sound does not need to travel as fast to, you know, or, wow, that was a bad explanation. Basically, at sea level, sound is going to travel faster than it does up here, and since we are now entering interface, it's slowly decreasing our Mach number because we are gaining airspeed, but we're losing speed relative to the surface. And slowly descending here. Time accelerate seems to be freaking out the capsule for some reason, so I didn't want to use it too much. But we'll go ahead and slap it on for now. We still haven't actually picked up a fraction of sea level density. That's this is the current density of the atmosphere compared to what it would be at sea level, with 1 being sea level. And you'll see as we enter here, we are going to probably, it looks like we're coming in over ocean. Yeah, we'll probably land in that sea right there. And there we go. We've picked up the first 1,000th of sea level atmosphere. And that's going to start increasing as I decelerate again to try to get yet again back on this flight path, because let's try killing the SAS. That seems to have fixed it a little bit. And here we go, entering. We're going to see some shock heating here as that heat shield protects us as we barrel through the atmosphere at an extremely high rate. I believe probably at this speeds, hitting the atmosphere would pretty much be the equivalent to hitting, well, almost something like concrete or dirt. And you can see your Mach number still decreasing there as we fall on in. And actually, we are going to come down over land, it would seem, in the desert. So we're going to pay very close attention to our altitude relative to the sea level, because we do not want to land. I mean, we do not want to deploy the parachute late if we, because this is going to be sea level altitude, and deploying the parachutes, at about 1,000 meters, thinking that the using this and assuming that the ground is actually at 0 is a bad decision, because you will impact. So we're going to go ahead and we're at about 2 kilometers up now. Now would be a good time to go ahead and deploy the shoot and drogue mode. And we're going to just coast on in here. We're going to pull it out at, we're going to pull out a time acceleration of 500 meters as usual. And then have our nice leisurely descent to the surface as we have deployment. And this time, since we did not have any crew reports in space, I do not know. Let's do a crew report from here. As we're falling in, it gives us 3.5 science. And then when we hit the ground, we will do another crew report and an EVA report, and we'll take a surface sample of this desert. And there we are on the ground. We got $36,000 of our payout. So we're going to do a EVA report. We're going to get out here and hang on to the ladder, and we're going to do an EVA report. And actually, this is taking us from the surface. Very loud noise there. And take a surface sample, and that's 9 more science. We're going to hop back on board, and we're going to go ahead and recover this vessel. And then we should probably wrap for this episode, because I'm looking at my timer here, and we're right at the 20-minute mark. So that's excellent. We'll go ahead and spend our science that we earned at the beginning of next episode as usual, pending any more save disasters. So thanks for watching, guys, and see you next time.